guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are going to talk about different quantum computing algorithms, and once again we are going to talk about another type of quantum computing algorithm that is the amplitude amplification algorithms. So basically we're going to talk about two algorithms that are in this type of algorithm. So let's start. Alright, so basically what exactly is the amplitude amplification algorithms, or algorithms that are based on amplitude amplification? So basically this algorithm works by allowing the amplification of a certain subspace of a quantum state usually. So usually the application of this algorithm will lead to an exponential increase in the speed of problem solving if we compare it to other classical algorithms. What I can say here is that it not only leads to exponential speed increase, but it's gonna lead to quadratic speed increase. And finally, also this type of algorithm is mostly used, when it's used to describe availability bias or cognitive heuristics. So basically it's used in not plenty of fields, but usually on a quantum level it can be used on plenty of fields. And mostly the algorithms that we are going to talk about can be used in cryptography, can be used for counting, can be used for problem solving, or can be used also for statistic purpose. So the two algorithms that we are going to talk about today will be the Groover's algorithm as well as the quantum counting algorithm. And basically the Groover algorithm is a quantum algo that is able to define the unique solution to a black box function, and all this with the very high probability. So basically the black box can be used in plenty of fields. It could be in engineering, could be in physics, and it could be in mathematics. And basically it can be applied to pretty much any type of problem that we don't know the inputs. So also the Groover's algorithm is not only providing exponential growth and speed, if it's compared to classical algos, it's providing quadratic speed up. So as I said in the beginning, and in other words, it can be really useful in many things. So for example, cryptography, since it can brute force really advanced systems in small amount of time. So in other words, what exactly is brute force? So in hacking in general, not in hacking, but let's say for example you want to find a certain password, and there is a technique called brute forcing. So when you are brute forcing, you will simply test all the possible strategies, and what exactly this algorithm can allow you to do is to test all these strategies in a very short amount of time. So let's say for example you have a 64-bit system, 128-bit system, and basically you will have encryption key. You will have millions, if not billions, of different possible combinations, and basically this algorithm is able to test all of those combinations in a pretty short amount of time. So basically by using it, you will be able to not destroy the modern cryptography, but it's gonna be a big hit in modern cryptography and modern security. So basically this is why this is why quantum computing could be a really good thing, but at the same time some fields such as security can see it as a threat. And with quantum computing, when quantum computing will become more available, the security will definitely need to be upgraded, because it will be pretty simple to brute force any password with any quantum computer. All right, the second algorithm right here will be the quantum counting algorithm, and it's a quantum algorithm that is used to count basically the number of possible solutions that a certain problem can have. So once again, this is really on a basic level, and it can do it in a really efficient way. So basically this algorithm is also based on the Groover's search algorithm. It's based on the algorithm right here. And also in this field, in the field of quantum computing, this algorithm is pretty important since it allows to perform efficient quantum counting. And finally, this algorithm offers solutions to the quantum existence problem. So basically this algorithm right here could be really used to, as I said, counting solutions to problems. But what I'm saying, counting, it's not only solutions, it could be used in really advanced statistics. It could be used, I don't know, well, usually in probabilities and statistics. And with quantum computing, it's possible to, well, basically use the statistics in real time. So if we want to talk about the modern world and in what field of the modern world it could be used, we can, for example, think about high frequency trading. So basically with the quantum computing implemented into high frequency trading, those businesses will have a really big advantage by using quantum computers, because it will allow them to make transactions at the second. Even now they have really advanced technologies, but with the quantum computing it's going to be even bigger. And this algorithm can be one of those algorithms that are used to basically count probabilities on a certain transaction or on a certain event to occur. So I hope you guys right now understood all the basics of this type of algorithms. So we talked today about amplitude amplification algorithms, or algorithms that are based on amplitude amplification, the Groover's algo, and finally the quantum counting algo. So that's it for this class, guys, and see you all in our next class.